Hello students, measurement of time. It is our topic today. And it is the last part of chapter 1. So we will begin with simple pendulum. Well, what is a simple pendulum? So it is a tiny heavy bob attached with the string which is inextensible and negligibly massive. Actually, massless is written in your books, but negligibly massive is the correct statement. And it is connected to a rigid support. Okay. Next topic is oscillation. What is an oscillation? A to and fro motion is called oscillation about a mean position. So, what is one complete oscillation? So, let us suppose this is a pendulum. When it goes to one extreme position, then it goes to other extreme position and then returns back to mean position. I mean, it doesn't stop there, but if it retraces its mean position once again, then we will call this as one complete oscillation. Like if this is a pendulum, goes to and fro, at the moment when it again comes to its mean position, it is considered as one oscillation. Next is time period. Time period, simply time, but certain condition with that. Time period, it is the time taken to complete one oscillation. Means one oscillation means to and fro and again mean position. So the time taken in that one oscillation. So it is denoted by T and it has SI unit second. Another thing, time period can be measured by if you set a pendulum for number of oscillation. Let us suppose n number of oscillation, 1 2 3 4 5 6 10 20. So I'm just writing it n. So if there are n number of oscillation, I'm using capital N number of oscillation. So time taken upon number of oscillation, so it will give you the value of time taken by one oscillation. Next, frequency. Symbol is F or small n. That is why I haven't used small n for number of oscillation. Okay, here I will just explain. It is time taken upon number of oscillation. That is why it becomes time taken by one oscillation. In the denominator, if everything will get cancelled, one remains. So in one oscillation, how much time will it take? Frequency. Frequency is opposite to time period. It is the time taken, it is the number of oscillation per unit time. Frequency is number of oscillation per unit time. So clearly it is just reciprocal of time period. It has unit per second or hertz. Then comes amplitude. Amplitude is maximum displacement from mean position. That is, if it is the bob, it has gone this extreme position to this extreme position, then mean position. So this distance from mean position to extreme position is called amplitude. Okay, next, the big one. Relation between time period, length of pendulum, and acceleration due to gravity, which is denoted by small g. Well, actually, you people right now don't know much about acceleration. Well, acceleration means how much rate speed is increasing, and it is somewhat related with force also. So we all experience gravitational force. So when anything falls, its speed increases, and the rate by which speed increases is called acceleration due to gravity. So acceleration, previously in first part we did some formulae, and in those formulae there was acceleration also and acceleration due to gravity also. So it is simply acceleration, just but this time we are not interested in that thing. Just we have an alternate formula for time period. It is 2 pi. Its derivation is not in your syllabus, so no concern about it, but just memorize this formula. I hope you will easily able to do it. All right. So now If we square both sides, t square 4 pi square, here root will get removed, L by G. I hope this is clear to all of you. All right, so with the use of the concept of this simple pendulum, we can find the value of G. So G is equal to 4 pi square L by T square. That's it. I think not a big calculations are there. So looks so simple. T equal to 2 pi root L by G. This is the one thing you have to memorize. Then squaring both sides, T square equal to 4 pi square, 2 to the 4 pi square. And here root will get cancelled. All right. Now what I did, just I have taken G here and T square here. Cross multiplication. Now one more thing that is going to be bit problematic for you people. I am writing it like this. So when this fraction will be solved, this L will go up. Why I have written it like this? So there is a reason behind it. So what happens actually, graph between T square versus L. If we plot, first thing, if we perform simple pendulum experiment and we take number of values and we find time period at different lengths. I mean, first time, let us suppose you took 2 meter length, then find the time period, then 1.5 meter, then 1 meter, then half meter. So you will get a set of lengths and corresponding times. And then you have to square those times. Let us suppose, as mentioned in your textbook, so I'm also using that length, and directly I'm falling into time period. So length 25 centimeter, 36 centimeter, 49 centimeter, and 64 centimeter. And what time period they are finding? 1.2, it is in seconds, and 1.4, 1.6. So then if you find square of this T square, which is this, and then find T square by L. Well, you can see your books. There they have done it L by T square, but actually T square by L will be much convenient. So it will come out to be 1 upon 25, or around about, actually here it is equal to 0.04. So all of them will come out to be equal. Okay, you can calculate it by yourself. Okay, so it means that this ratio will remain constant. And if we plot graph, we will mark. I hope all of you know how to plot graph. So here we have these value. We can take a graph paper and we can mark accordingly. And this axis, we are not using t, we are using t square. Again we will mark. And when we plot graph, the big surprise is we will get a straight line with a constant slope, a particular slope. And as I told you, G equal to 4 pi T square by L. Graphically we write it G equal to 4 pi upon slope of T square versus L graph. So what does it mean? Actually slope, how will we calculate slope if I'm taking it as a whole? So this entire value is T square and this value is L. So ultimately slope is in a right angle triangle, slope is the ratio between perpendicular and base. Slope is perpendicular upon base. So you can take a small part of it also. Then this value, let us suppose this is AB. So AB upon BC. What is A? Some T square. What is B? Again some T square on this y-axis. Here along L, What is C? Some length. What is B? Some length. So just remember these two formulae. So few more things like time period of pendulum depends upon, we can write dependence of time period. So as I told you, its formula is T equal to 2 pi root L by G. So you can say time period is directly proportional to root L. Means how much, if we increase L, T will also increase, but that doesn't mean that that equally increases. It is in the root form, so it slowly increases. First thing. Second thing, time period is T of pendulum inversely proportional to, okay, sign is always this, inversely means 1 upon. Okay, so we can say directly proportional to root of L, and here inversely proportional to root of G. That's it. Does mass play a role in this? No. T is independent of mass. Fourth, does it depend upon amplitude? T is independent of amplitude, which is written in your book, like extent of swing, how much far it has gone from mean position. So that is extent of swing. So it is independent of amplitude, but there is a condition. Small amplitudes required. It doesn't mean that it depend upon amplitude. Actually, small amplitude means it is not, you should not oscillate pendulum like swing, park swing, huh? Not like this. It should be small oscillation. Okay, otherwise air will affect its oscillation and it will not perform with a constant time period. So a small oscillation, they will perform constant oscillation. All right, so finally there is another concept which is called seconds pendulum. What is a seconds pendulum? It is a pendulum whose time period is 2 seconds. Name is seconds pendulum, but actually its time period is 2 seconds. So another thing is seconds pendulum, its time period is 2 seconds and its length 2 seconds, sorry, and its length is approximately 1 meter, slightly less than 1 meter, actually 0.99 centimeter, 0.99 meter, I mean 99 centimeter. So that is seconds pendulum. Why it is used? Actually, earlier it was used in pendulum clocks because it has a fixed 2 second time period. Then we calibrate it and set our clocks to set into 1 second time period. I mean 2 second it has its time period, and we make some mechanical arrangement so that the clock, the arm of clock will go 1 second after each oscillation. So that's all. Just revise it on the points which I discuss, prepare notes, and the exercise part we'll do tomorrow, and we will just start next chapter also.